Now, another one. I don't know if you're going to be able to see this right. This is really good, this pylon. But you might, can you see two little tiny bumps in it? Two little tiny bumps. There's not a groove in the center. Now, what that's telling you is that even though there was a groove initially, when you rotated the prosthesis 180 degrees, after you got your vacuum, now the seam was up on the top side, and the weight of the seam was helping to reinforce it. And because you did that 180-degree rotation, you've been able to, the thermoplastic to fill in that surface completely. That's why you see two little beads instead of one. I think I have another one that's a little bit more dramatic. This one here. You'll see two little tiny grooves. Two little tiny grooves. And that's telling you that initially there was a large groove, and then when you rotated 180 degrees, the seam area actually helped to weight that joint and fill it in with hot material at the time. Now, what you're also evaluating for is the pylon wall thickness. If you look at this one, this was a 3/16 prosthesis. If you notice, the pylon wall is generally thinner. But if you look closely at it, you'll see that it's even thinner on the posterior side. Now, when it's thinning on the posterior side, what does that tell you? It tells you there's less material on the posterior side of the pylon is where you want more material. So you got to be real careful. Now, if you're using the the cutting template when you're cutting your material, this should not happen. If it does happen, that means you're pulling the plastic down too much before you get your vacuum, and it's actually thinning, and you're thinning the plastic before you get your suction. So be careful on the pylon area as you're vacuum forming. You don't want to be pulling the plastic down. Just let it lay on the mandrel, touch the seams together, and let the vacuum draw it up. Do not pull it down, because that's what's going to happen. You're going to end up with a resultant of a thin posterior pylon wall, and that can be very dangerous. Again, for a 3/16 project, this is pretty acceptable. You just don't want to go any more than this. Here's another interesting one. I don't know, maybe you can get in there. This is another example of the fact that since it was rotated 180 degrees, we were able to save the system. Okay? Now, we also, if you want to get involved, take a look at this one too. Now, that one filled, but didn't fill completely. We highly recommend that if you decide to take this video education and go back to your facility and make your prosthesis, we highly recommend that you test these pylons and study them. We would even appreciate it if you send them to us for our evaluation. What we do is freeze them and bead them and put them through all kinds of tests after they pass the visual test. And we'll be glad to call you back and let you know if there are any problems, and we can work them out over the phone. But this is a very critical part of this whole system. This is a beautiful one right here. See, the wall thickness is uniform, the seam is pulled all the way in, and these are what we call pylon cutoffs. In fact, sometimes we have students say, you know, I learned how to make the EndoFlex someplace else. Will you send me foot clamps? I said, sure. Send me some pylon cutoffs and I'll look at them. And if they don't know what I mean by pylon cutoffs, I know they're lying to you. All right, now, I'm going to go over the pediatric model. This is the pediatric prosthesis. It's made the same way, but if you notice, there are stackable lengthening wafers on top of the foot clamp, below the foot clamp. And you start off fitting it down on the foot, you actually add lengthening wafers as you go along. But this prosthesis is made the same way, only it's made on a piece of half-inch stainless steel rod instead of half-inch galvanized plumbing pipe. Very light, very dynamic. A left socket with the right foot. Okay, these are the foot clamps. They come in 3/16, designed for 3/16 application, where you mold 3/16 material, and also the 1/4 inch. This one's a little bit larger, can handle 1/4 inch material. On the outside, they're almost identical. They're almost identical. Any way you look at them, that's the reason why we mark them, because they're very difficult to tell the difference. Here's the adult lengthening wafers. So in case you want to lengthen the prosthesis for any reason, these are available. These are also nylon machine. This is something we're working on right now for the future, which is an injection molded polycarbonate foot clamp. And the reason why we're looking into this is because, as you can see, now instead of all the measurements, you can see whether your pylon is all the way down inside the foot clamp without having to fool around with it. This also is about 40% lighter than a nylon foot clamp, but it hasn't matched the nylon yet in durability, so it's not available just as yet. But this one actually works pretty good for a swimming leg or a shower leg. We use it for those reasons. Now, EndoFlex has also gone to the 8K, and what's available with the 8K is a 3-piece system. It comes, the 8K dynamic pylon comes a 20-foot length of pylon, and if you notice, it's got a portion of it that's a larger circumference than the smaller circumference. So the trick in manufacturing this, when you utilize the system for your patient, is depending on how flexible you want your pylon, that determines what side you want to cut the material down. So if you want it more rigid, you're going to cut more off this side. If you want it more flexible, you're going to cut more off this side. But remember, when you're working, if you're going to mount this all the way up to a knee that has no hydraulic unit or anything like that, you're looking at 16 to 18 inches, maybe 20 inches of pylon surface. So even though this is the largest circumference, it does have some flexibility, which I'll demonstrate. Now this kit comes with the foot clamp and a bolt receiving 4-bolt pattern plug that fits onto the top, and when you finish, you put 2 stainless steel sheet metal screws in the posterior side here, the same way you do on the bottom section. And it comes complete with the 4-bolt adapter. Pass the 5G test. Comes with the 4-bolt adapter and the foot clamp as well. I think this is what, $145. Very reasonable price for a dynamic pylon. And I'll show you how it works. This is an 8K setup with an EndoFlex pylon on it, okay? We love them for the geriatrics. They're real smooth to walk on. It's not very responsive for an active guy, but if you're going to go with a hydraulic unit, you're only going to be left with a short amount of pylon anyway, and at that point it would be appropriate. But for the geriatric, you like to do them just like this, because look at push-off. Okay? So if you're walking at a slow cadence, this is real smooth to walk on. And I can really flex the life out of this if I wanted to. Okay? But again, you'll see that it's still even flexing on the proximal side. Not as much, but it does have some degree of flexibility. All right. Anything else with the 8K? That should be it. This is a kit. These are the things you need to manufacture the EndoFlex. This is the way the kit comes. These 3 different length molding cones and 2 retaining rings, stainless steel retaining rings in the kit. And the ActiveFlex. The ActiveFlex is an installation that you may want to do later if you want to stiffen up the pylon, okay? And the way it works is you use a longer bolt. Usually with a standard foot, you're going to want to use maybe a 4-inch bolt. If you're using a Seattle Lightfoot that mounts a little shallower, you can still get away with a 3-inch bolt. But what you do is you set it up so that the bolt is extending through the bolt receiving shank inside the EndoFlex foot clamp, and you need about 1 inch of thread here. And once you get that put together, at that point, you can just screw the ActiveFlex right on top of it, and this will end up being sandwiched inside the pylon and dramatically stiffen it. We also use ActiveFlexes if we want to keep the weight of the prosthesis down to a minimum for, say, a 150 or even 160-pound patient. We can use 3/16 material and then put an ActiveFlex inside, so that overall the prosthesis is going to be dramatically lighter, because the whole prosthesis is using 3/16 as opposed to quarter. And the additional weight of the nylon is not as much as if you were to go to 1/4-inch material. So we have some cases where we want to keep the weight of the prosthesis down, yet make it a little bit more rigid for these same people, and we'll install an ActiveFlex in those cases.